Hello everyone, this is Priyanshu Choubey, assistant professor in Physical University. Today we will talk about the soil color and the soil color chart that is used. So let's see what is a soil color and their importance and factor in influencing our soil color. So let's see what is a soil. Color chart is used to match soil to a standardized color. Certain color indicate a content of the soil. Black high organic humus contain white calcium deposit. Red orange iron oxide or rust. Gray blue iron in reused state can indicate a standing water. So, a standard system soil color provides valuable information regards soil condition and some properties of a soil. For example, dark colored soil absorbed more color radiation and warm up faster and then the light colored soil color is also used for soil classification and interpretation and description of a soil profile. And the presence of excessive salts, soil origin, etc., can also be easily identified for a soil color. Determination of a soil color, a standard system of accurate description of a soil color involves a Munsell color chart. It's a Munson color chart showing on here. Munson color chart. It's a Munson color chart. Small pieces of soil is compared with the standard color chips in the soil color book. Each color chip is described by three components. First one is hue, value, and chroma. The hue is the dominant spectral color, which refers to usually a redness or yellowness. Uh, Hue is always showing a red and yellowish color, and dominant spectral color are available here in a soil. The value refers to the relative lightness and or a darkness of a color, amount of a reflected light, a value of 0 being a black. If a value having a 0, it means the soil color is black. Maybe it is light in color, and maybe sometimes a dark in color. The chroma represent the purity of the dominant color, strength of a color, a chroma of a 0 being a neutral gray color. So the Munsell color Munchen color notations are a systematic numerical and letter designation of each of these three parameters. For example, uh, uh, 2.5 YR 5 upon 6. It means hue is 2.5, YAR means value is 5, and chroma is a 6. So the equivalent soil color name for the Munsell notation is in a red. Soils have a wide range of colors of red, brown, yellow, and even a green. Some soil are nearly black, while some are nearly white. Adjacent soil may even have different colors. Is example, black and red soil exist side by side in Andhra Pradesh. Soil color may vary with depth in soil profile. And from place to place in the landscape, the soil horizon may have colors of a same hue but of a different chroma and value. So now is the most important factor influencing a soil color. A most important factor influencing the soil color, like first one is a mineralogy and chemical composition of a soil. That is the most important. Presence of manganese oxide imparts black, while ga- uh, uh, magnesium oxide impart a black, while an gluconite imparts a green color to the soil. If your soil having magnesium oxide, so it means your soil color is a black. If your soil is having a gluconite percentage is a high, so soil color sometimes exhibit a green color. So calcium carbonates having a which is a called calcium carbonate, which is found in a soil of a semi-arid region, imparts of white in color. So second most important factor influencing a soil color, iron compounds. So iron compounds when a soil having a iron compound, so soil color or exhibit a red, yellow or a brown color, is mostly related to the extent of oxidation, hydration and diffusion of iron oxide in the soil. Yellow, red and brown color are most due to a presence of the geothites and hematites and magnetites respectively. So organic matter presence in the soil tends to impart dark brown to black color. Soil moist soil are a darker in a color than a dry soil, and soil texture and structure also important. Porous structured soil are usually light in color, while structured soil appear to be dark in a color. So soil color is the most important for soil. And soil color provides valuable information regarding the soil condition and some properties of the soil. Already we discussed about dark colored and soil absorbed a more solar radiation and warm faster than the light colored soil. Soil color is also used for a soil classification and interpretation of description of the soil profile. The presence of the excessive salts, erosion, etc., can also be easily identified from the soil color. Hello everyone, this is Priyanshu Choubey, Assistant Professor of Soil and Bihar University. Today we will going to talk about a structure. Soil. What is a soil structure and uh, soil aggregates? So let's see what is a soil structure. Soil structure, it is a particular importance in the absorption of the water and the circulation of air. A desirable structure should have a higher proportion of medium size aggregates and an prescribable number of and an appreciable number of the large pores through which water and air can move. Structure of both the B horizon and the A horizon is a very crucial to a proper drainage in infiltration and productivity in soil with a poor structure root penetration in limited, thus the reducing the plant's access to water and nutrients. The structure of the A horizon has received a great deal of attention because of the its relation to seedbed preparation, B horizon potential aeration, water infiltration, overall soil health. So let's see soil structure. The primary soil particles do not exist as um, such in a natural condition, but the bonded together into a large units of aggregates, usually termed as secondary particles. These aggregates formed under a natural condition are called pads. Whereas an irregular shaped coherent mass of soil formed during a tillage operation is called a clod. Soil structure is defined as the arrangement of a primary and secondary soil particle in a certain structure pattern. This arrangement result in information of different sized pores. Therefore, a soil structure may also be defined as the arrangement of the various sized soil pores in certain structure pattern. So now is the important of soil structure. Soil structure influence almost all the plant growth factors like water supply, retention, aeration, availability of a plant, nutrient, heat, root penetration, microbial activity, and etc. Strong aggregations decreases uh, decrease detachability and transportability of soil particles by water and wind and thus reduce the runoff and soil erosion. Solid structure is useful for a classification of soils. It is affected by a tillage, cultivation, and application of fertilizer, manure, lime, gypsum, and irrigation. Classifications of soil structure. Uh, Soil structure is described and classified based on the types of the type as determined by a shape and arrangement. The class as a differentiated by a size, and third one is the grade as a determined by a distinctness and the durability of pads. So types of structure based on shape and arrangement of a pad. Solid structure is classified as a simple and the compounds, and simple structure, natural cleavage, planes are absent. Simple structure is of two types: uh, simple granite and massive. In granite structure, particles are completely unattached to each other, as in case of a loose sand and While in a massive structure, particles are the bonded in a large cohesion, non-structured mass in case of a surface crust, plow pane, and the clay pan. In compound structure, natural cleavage planes are visible with a naked eyes. This shape are individual paired and described according to relative length and vertical and horizontal axis by a shape and their edges. Compound structure is four types of depending upon a shape and their characteristics like first one, types of compound soil structure and their characteristics. Type one is a blocky all the shape and characteristics of a blocky, all the three dimensional of a pets are of about same size, providing a shape of a block having a flat and rounded face. These pets are further divided into a angular blocky and the subangular blocky. In the former face are a flat and the edges and corner are sharp, while in the letterfish and the edges are mainly rounded. The blocky structure usually found in a B horizon and promotes good drainage, aeration, and root penetration. Second one is a prismatic. The pads are analogate more in vertical than in a horizontal direction. Given a column-like shape, vertical cleavage planes are the predominant. When the top of pads are relatively angular and flat, is called a prismatic, and when rounded, it is called a columnar. Prismatic structure commonly occurs in subsurface horizon in a arid and semi-arid region, and poorly drained soil of a humid region having a swelling type of clay. Horizontal axis is longer than a vertical axis, resulting the plate-like appearance. Horizontal cleavage planes are predominant. When the pad are s- thick, they are called platy, and when thin are called laminar. Platy structure is often inherited from a parent material and may also be formed due to a compaction of a clay soil by a heavy machinery. Plate structure restricted infiltration and percolation and aeration soil. Spherical pits are roughly spherical and granular and subdivided into a granular and the crumbs. Granular structure is less porous than the thumb due to a low organic matter content. Spherical structure formed by a biotic activity in surface horizon and promotes infiltration, percolation, aeration, and root penetration in soil. Classes of soil structure on the basis of size aggregates. Each type of soil structure is further subdivided into five classes. The size of aggregates is a certain of quantitative classifications. of soil structure, coarse and sand size aggregates are more favorable for plant growth, and very smaller or very large aggregates. So grade of soil structure. Grades of soil structure, it is a qualitative means of the classification of soil structure. Qualitative means of classification of soil structure. Grades of soil structure are the identified on the basis of the stability of the grades. Stability of a grades refers to their resistance to dis- disruption by impact of raindrops under a submerged condition. It is influenced by a moisture content amount and type of clay and nature of the adsorbed cation and organic matter content of a soil. High moisture content, colonite clay, developed cations, and high organic matter content make the aggregates relatively soft. Three structure grades have been identified as a weak, moderate, and strong. So, grades of soil structure. To describe to soil structure, the sequence, grade, class, and type of the followed for example: strong, porous, angular, blocky, moderate, thin, platy, and weak, fine, prismatic structure. Like a great weak, first one is weak, so characteristics are poorly formed, indistinct pads with which are not as stable. Moderately developed pads which are fairly stable and distinct. A strong, a very well developed pad which are quite stable and distinct. So genesis of structure refers to the uh, cases and method of formation of aggregates. The following two processes are the involved in the genesis of structure. First one is a flocculation. Flocculation. Flocculation, it is an electrokinetic phenomena is in which positive and negative charge are involved in a soil water suspension, and the clay particles with a high zeta potential repel each other. With the addition of flocculating agent, zeta potential is lowered. The particles come closer and attract each other, resulting in the formation of floccles of silt size. Floccles are stable as long as the flocculating agent is present. Flocculations also take place due to hydration, high soluble salt concentration, and the presence of the divalent or trivalent cations. Cementation of floccles.
It refers to consolidation of a clay foccolates by a cementing material so that they may not get displaced once these have been flocculate, as flocculates are not a large than a silt size. Therefore, flocculations would be unfavorable for a plant unless these are further aggregates by inorganic calcium carbonate oxides of iron and aluminium and organic matter cementing materials. Flocculation of a clay particles is therefore the request for aggregation. So aggregation is always refers to a flocculation plus where a plus in the cementing agent. Factors influence the formation and the stability of the soil structure. So first one is the physical factors. Physical factors includes the wetting and drying and freezing and thawing. Alternate wetting and drying leads to a formation of a smaller aggregates, particularly in the fine texture soil. Drying causes a shrinkage of the soil mass, and when the large dry cloud is wetted, rapid entry of water causes unequal swelling in the cloud, and the cloud is fragmented along the cleavage plane. In the process of wetting, increasing the pressure of the interrupt air cases distribution of the large cloud into a smaller pieces. Similarly, freezing cases cracks in the large plot by expressions of a water. These cracks cracks takes in a more water upon thawing and get enlarged further of the refreezing. Chemical factor. The chemical factors includes the exchangeable cation and the binding materials. Clay acts as a cementing agents, also swells shrinkage upon the wetting and drying. In certain also small aggregates are held together by a covering of the clay particles. Exchangeable ions such as the calcium, magnesium and potassium have a fluctuations effect on the clay, while sodium has a dispersing effect. The sodium ions dominating on a exchangeable complex of a sodic soil cause particles or repel each other and hinder the formation of the aggregates. The divalent cations such as the calcium and magnesium causes the individual colloidal particles to come together and form foccolates. Calcium also help in binding the organic colloids and clay particles. Hydrate Swaxe oxide from almost completely inversible collide upon dehydration and the uh, and help in forming stable aggregates as in the lateric soil, oxysol and alti soil called the lateric soil of the humid tropics. So Swaxy oxides also formed a complex with humus and calcium carbonate precipitating around soil particles act as the cementing materials for aggregates and imparts a stability to soil aggregates, a soluble salt, and to enhance the flocculation of the clay even in the sodium saturated clays. Organic compounds play a key role in aggregation and stabilization of soil structure. Fat, wax, lignin, protein, raising, etc. also help stabilizing the soil aggregates. Humans help in the aggregation by the forming clay humus complex. Only a calcium humus is a flocculate flocculating due its tendency of a form a complex with organic compounds through the the coordinations linkage the magnesium potassium and hydrogen and sodium humans is defocculated and does not help in aggregation synthetic soil conditions. Long carbon chain organic compounds are also used for soil aggregation. These compounds attach time wells to the inner exchange sites of the clay and the bind the clay particles together at addition of these compounds in relatively small amounts and can produce a good structure even a sandy soil. Biological effects, biological factors. Biological factors, the plants and plant residues help the soil particles to bind together. Um Gelinations, organic compounds extruded from a root binds and soil particles together. Root hairs penetrate soil clots to create a point of the weakness and ultimately break the clot into aggregates. This also helps the soil particles stick together in a granular form. Plant residues serve as a food for microbes, which play a prime role in the aggregates formation and the produce sticky substance or decompositions. Microorganisms decompose plant and animal residues form a humus, and this humus binds the particles together. Algae, fungi, actinomycetes, and bacteria, which continue the living matter in a soil bind. Soil particles more effectively than the exchangeable ions. The small animal like rodents, earthworm, spiders, mites, nematodes, insects, centipedes, and millipedes, etc. Uh, Facilitate the formation of soil aggregates by way of borrowing, turning the soil, or throughoutly. Mixing the organic residues with the soil. Evaluation of a soil structure. The soil structure can be evaluated both of a direct and indirect method. A indirect method soil structure is characterized by the observing the shape, size, and arrangement of the soil aggregates either microscopically or a microscopically and microscopically. In microscopic technique, thin soil section are examined under a various types of microscope for shape and size of aggregates and voids. For microscopic evaluation, are large soil clouds in clouds. It's excavated from the field and allowed to fall gently on a smooth surface, which breaks into pads of a different size and shape. Shape and size can also be observed directly from the cleavage of the pads in the soil profile. Indirect method involves a measurement of the size distribution of stable aggregates, stability of aggregates of the soil property, which is the function of soil structure. Soil is indirect method, size distribution of stable aggregates. So, dry or wet sheaving techniques are used for determination of different size stable uh, aggregates. In direct dry sheaving techniques, the proportion of a stable aggregates against a vibrating action stimulating of the scoring effect of wind is determined, which the provides and the index for a characterizing the susceptibility of soil to wind erosion. In wet sheaving technique, size distribution of water stable aggregates in determined. Measurement of the stability of aggregates. It is evaluated by the degree of the which soil aggregate resist dispersion. Several indicates have been developed, such as the stability index, structure coefficient, and dispersion coefficient. Stability index and is the difference between a percentage silt and clay as determined by the mechanical analysis and that the obtained by suspension of soil sample in water. The great the difference, the better in the soil structure. Structure coefficient is given by uh, d minus s upon s, where d is a percentage of particles less than 0.25 mm in diameter as determined by the mechanical analysis, and the s is the percentage of the aggregates smaller than 0.025 mm in diameter as determined by the wet sheaving method. High the value of the structural coefficient, the better is the soil structure. Measurement of the soil properties: bulk density, infiltration rate, hydraulic conductivity, aeration, available soil water, degree of compaction of soil may be used for evaluation of soil structure. So indicates of a soil structure: amount of a different size soil aggregates is represented by the single value of the comparing the structural status of different soil or the same soil under different management particles. Among various indicates mean a weight diameter of the aggregates is a commonly used index of soil structure. The mean weight or diameter of aggregates gives an estimate of a weighted a percentage of the average size of all the aggregates. The proportion by weight of the given size friction of the aggregates to the total sample weight is a multiplied by the mean diameter of the that frictions. The sum of these products for the all size frictions gives a mean weight diameter of aggregates in a mm. uh, Management of a soil structure. So the general practices for improvement of the maintenance of the soil structure: tillage operation be carried out within the range of the optimum moisture condition to ensure least destruction of the soil aggregate. Zero and minimum tillage practices be adopted to maintain adequate aeration and reduce the loss of organic matter through oxidation of erosion. Soil surface be kept covered with the crop residues to protect aggregates from the beating action of raindrops. Check wheat emergence and add organic matter. Incorporation of the crop residues and the manures into the soil for the stabilizing aggregates. Introduction of legumes in crop rotation coupled with the application of the phosphatic fertilizer. Green manuring and cover crops are a good source of organic matter. Integrated use of organics and fertilizer for crop productions. Some soil have a specific structural problem which need a proper soil management practices for a better soil structure. Sandy soil. This soil have a problem of low water and nutrient retention. Retention. The practical method of improve structure of the soil, such as soils, is to add organic matter directly or through a green manuring. The addition of the pond sediments, can clay soil or even a compaction is helpful in increasing the proportion of small size pores for the enhancing uh, water and nutrient retention capacity. Clay soil, these soils have a restricted drainage and the aeration due to a poor aggregations. Addition of a soil matter through a helpful for improving aggregation, but the required amount is high. Therefore a crop rotation and use of phosphatic fertilizers are useful. Raised or raised bed cultivation can reduce the aeration stress problem to some extent. um, Padlet condition in areas under prolonged waterlogging, the soil aggregations are broken, leaching to padlet condition, a poor drainage, and possible solution of a soil problem. Disparate condition, the problem of dispersion is found in a sodic soil. Addition of a gypsum is a combination with the green manuring, manures, or the incorporation of crop produce in a successful in the improving soil structure and the ameliorations of this soils. Low stability of the aggregation in the soil of the airy and semi-arid region. Due to a low organic matter content, stability of aggregates can be increased by the addition of the organic matter. Mulching may also be useful as it provides a favorable condition of the microbes to decompose organic materials. Influence of the texture and structure on the soil porosity and pore size distribution. The porosity of pore size distribution in the soil are affected by a soil factors, mainly texture and structure. The organic matter bulk density and management factor like tillage and cropping and irrigation, which affect the soil structure, indirectly affect the total porosity and pore size distribution. It has already been mentioned that the porous textured soil have a low total porosity than the fine textured soil. Although the size of an individual pores is large in coarse structured soil, the porosity in clay soils is a highly variable as the soils exhibit a swelling, shrinkage, and aggregation, dispersion, and compaction and cracking upon wetting and drying. The fine textured soil have a large proportion of the microbial proportion of micropores. Therefore, this soil retention, higher amount of water and are generally poorly drained. Sandy and loamy and clay soils may have total porosity in the range um, 30 to 45, 40 to 55, and 45 to 60% respectively. Distribution of the different size of pores is more important for plant growth than the total porosity. In sandy soil, most of the pores are relatively large and nearly of a uniform size. Hence, once these pores get embedded at the given sections, Sections only a small amount of the water is held in the soil, while is the clay soils are the pore size distribution is a more uniform. Therefore, the water gradually decrease with the increase in suction. The amount of the water retention at relatively low suctions less than uh, 1 bar depends primarily upon the capillary effect and pore size distribution, and hence strongly affected by a soil structure. Water retention in a high suction range in due to surface absorption and influenced mainly by a texture. Soil compaction decrease a total porosity, especially by reducing the volume of large linear aggregates pore, thereby resulting in a decreased water content at a saturation and low suctions. The volume of the intermediate size pores in the large, but the aggregates micropores remain unaffected by the soil compaction, and for this reason the soil moisture retention for the compacted soil aggregates soil may be nearly identical at a high sections range. Quantitative relationship between a soil constitutes soil texture and soil structure largely influence the weight and the pore spaces of the soil. With the increase in the bulk density, the volume of pores decrease and vice versa. Major interest is therefore in studying the relationship between a bulk density or a pore spaces as a water and air and stored in the and move through the pores. Plant roots and other soil organisms also require pore spaces for their growth and development. So here completed soil structure, um, how to management a soil structure, evolution of a soil structure, direct method and indirect method of soil structure, genesis of a soil structure, factor influencing formation on stability of a soil structure, and types of compound and soil structure and their characteristics, classification of soil structure, importance of soil structure. Here completed. Next slide we will see bulk density and particle density and relation between bulk density and particle density. Thank you.